Our next presenter is Dr. Palen, presenting the slides of Dr. Johnston.
That was my prompt.
You left your what?
Oh, your prompt.
I am so glad that all of you could be here to hear this innovative talk about innovations, not only in the classroom, but in fact, in the entire universe. In fact, I'm going to be telling you about an infinite amount of innovation, because the universe has been infinite since the moment it began. Here we have a picture of a singularity. That's not to scale, of course, because if we did make the singularity to scale, then the entire universe would not fit on this plot, which it clearly does, being infinite. But I'll explain more about that in a minute. So, let's talk for a moment about how the universe could be infinite to begin with, and then become bigger. Because I'm fairly certain that your brains just exploded. Is that correct? Yes, yes, of course they did. So I used to think that this kind of explanation, that, for example, the number of whole numbers, physicists, how many whole numbers are there? 0, 1, 2, 3, 4, 5.
30 or so.
How many?
Around 30.
Around 30, right? But to all you young students, 30 seems like practically infinite. But now I want you to consider Brad. So then you can see almost right away how infinite 30 can become even bigger. And the way that that occurs is that, of course, stuff happens. And we don't want to talk too much about the stuff that happens between 30 and then, the really amazing thing about the universe is that not only did it start out infinite and then get bigger, which is amazing all on its own, and we can think about that for a while, but it turns out that the universe is getting bigger, faster, all the time. And that doesn't seem like a problem until you remember that F
Less than E.
F equals MA. Thank you, Celia. So F is equal to MA. So if the universe is getting bigger and faster all the time, that means it's accelerating. F equals MA. So if there's an acceleration that's very, very big, that's big enough to accelerate the whole entire universe, then there'd better be an F that's what?
Pretty big.
Very, very big. Right? And so we don't know what that is. And I say that as though it's a joke, but it's not. We have no idea. Theorists, dark energy, they took a box, put our ignorance inside, and carefully labeled it with a Sharpie. Dark energy. And so then, after that, what happens? Well, after that, it gets bigger, even faster. But this is a lie. Actually, a typo. It should say, we're not pretty sure we know what happened here. Right? So I apologize for that. You can ask me questions afterwards, or you're always, of course, welcome to come to my office and ask me questions about what I'm telling you about in this talk, when you can find me. Okay, so now I just want to review really quickly before we get to the last slide, because we really do sort of need to go back so that we get the whole picture of what's going on, right? So we start out here, singularity, not to scale, right? Very, very small, but at the same time infinite, right? And then we move me about that later. And now here is where we are today, right? Right here at the bottom of the PowerPoint slides. And not only do we not understand how the singularity started, or how the universe was infinite and expanded, or how it's accelerating and dark energy fits in a box, kind of like the dark matter, and we should stamp it out. But we also don't know about the other end of the PowerPoint slides. What's coming down here? And the reason we don't know that yet, well, there's kind of two interpretations for that. One is that we haven't gotten there, and the other is that it doesn't exist. So I'll leave you with that. Adam Johnston. Oh, so sorry, questions. Michelle.
So you started by saying that the cool word innovation, which I hear lots lately, and I'm being told to innovate.
Yes.
And can I use this to be innovative?
Absolutely. So, the thing to think about when you think about the beginning and the evolution of the universe is that it was really a big bang, right? So when you think about evolutions, you probably want to think about strategic explosions.
That's tactical.
Is that like the pre-Cambrian explosion?
No. I think this thing's slightly more targeted than that.
It's like a drone strike.
Yeah, that would be perfect. Yeah.
So there are three variables in that F equals MA equation.
Yes.
What about the other one that you haven't talked about? Like
Equals? So what that means is that one side of the equation can be substituted equivalent to the other side. This is a misconception a lot of students have about equals. They think that equals means it's the answer on the other side. But it really just means that the two things are equivalent. Next question.
So how does this explosive innovation fit into our current business paradigm?
I think it fits in the sixth sigma. Next question.
So, if the universe is infinite, so it includes absolutely everything, but it's expanding, then what is it bringing in from the outside to be able to infinitely expand?
Nothing. So the space itself, you just get more of it all the time. So let me ask you this. You get more time all the time, right?
No.
No.
Yes. This second wasn't ever there before. This second was never there before. This second was never there before. And Einstein tells us that space and time are really the same thing, so why are you surprised we get more space all the time?